Alright people, so welcome to Jumbo IS and welcome to this lecture series on current affairs. Now today we are going to cover 1 week's current affairs related to geography and environment. If you have been following this lecture series, you know this that we cover 1 week's current affairs in one lecture and we have segregated all the current affairs subject-wise. Today we are going to focus on geography and environment related current affairs from the past 1 week. Now, needless to say this, well, just watching this lecture would be job half done. You need to revise it from the notes as well. Okay, so please do not forget to do the necessary revision just after watching this lecture, because that ways you will be able to remember, retain these current affairs in your memory for longer periods of time. Now, the notes can be found on our Telegram channel, and the link to our Telegram channel is provided in the comment section just below this video. All right, okay then, let's begin today's session without much delay. So let's begin. So current affairs, geography, environment, June, part 4. Okay, now here are the topics that we need to focus on, or these topics basically dominated the news cycle of the past week. Number one topic is related to early season southwest monsoon deficit. Well, monsoon has been a little scanty this time, so the reasons behind that would be covered in this particular topic. Then we'll talk about surging thermal cooling demand because of summer heat waves, and how much pressure it is adding onto the already pressurized electricity grid of India. So we'll talk about this. Then we'll talk about pollution, ground level ozone concentrations. Generally, we focus on winter pollution, especially in the northern plains. But summer pollution, and the biggest pollutant for summer pollution is the ozone, and its concentrations are rising. Okay, so we'll talk about this. And in the end, we'll talk about an innovation to help agriculture, and that is smart seed coating technology. So what is the smart seed coating technology? How it would aid agricultural productivity in India and protect farmers from agricultural distress. We'll talk about this. So these are the 4 news items that we shall zero in our attention on. So let's start discussing them one by one, starting with topic number 1, and that is early season southwest monsoon deficit. Now look, we all have been hearing that this time around the monsoon is going to be not that well abundant, right? We all have heard about it, and the primary suspect for that is El Nino. But actually what we have found is that there are so many reasons behind scanty rainfall this monsoon season. What the data has revealed, and this data has been released by Indian Meteorological Department, it says that 75% of India's geography is facing rainfall deficit of more than at least 20% less rainfall. And the reasons behind this are many. It's not 1, it's not 2, it's not 3, 5 reasons. El Nino is just one factor. There are so many other reasons. Now, the reason why we are covering this topic is because it is important for your geography subject preparation. Why? Because monsoons is an important topic of Indian geography, and you need to know what drives monsoon in India. So the factors that we are going to discuss, which are responsible for less monsoon this year, are also the factors which, if in the opposite direction, lead to surplus rainfall. You need to be aware of these factors. Basically, you'll study about these factors in your geography session as well. So you need to know about them. Clear? So we'll focus on that, and then eventually we'll talk about the impact of deficit rainfall this monsoon season, the socio-economic impact on India. Clear? So let's focus on these two items in this topic. So let's begin. So early season southwest monsoon deficit. So what was in the news? Following a standard onset over Kerala on June 4th, okay, the northward advancement of southwest monsoon hit a severe structural block. By late June, data released by IMD revealed a staggering countryside rainfall deficit, 75% of India's total landmass experiencing acute rainfall deficiencies exceeding 20%. Okay, so this point is very serious. Now let's talk about those factors that are responsible for less rainfall. Okay, now remember, we'll study about these factors in detail in our geography lectures. Okay, right now just focus on remembering these 5 factors. Just focus on remembering them. What are they? How are they formed? What are the reasons behind these factors as well? I mean, the detailed discussion on each and every factor will be discussed in geography lectures. Okay, all right. So here are these 5 factors. First of all, we all know about El Nino, right? Whenever there is an El Nino event, there is shortage or rainfall. Monsoon is not that abundant. Then there is this another thing, MJO, Madden-Julian oscillation. Now, El Nino happens in equatorial Pacific. Madden-Julian oscillation happens in the Indian Ocean. It is a climatic or a climatic or weather-based phenomena that constantly shifts. Currently, Madden-Julian oscillation is in its downward phase, and whenever it is in its downward phase, well, Indian monsoon, the strength of monsoon winds are not that much. Clear? So this is Madden-Julian oscillation. Then another factor that is responsible for rainfall in India during monsoon season is Somalian jet stream. Okay, jet streams are upper winds. So Somalian jet streams, what are they? We'll talk about that in our geography lectures, okay? But remember, if Somalian jet streams are weak, monsoon is bad. When Somalian jet streams are strong, monsoon is good. Currently, Somalian jet streams are also weak. And the fourth factor is low pressure troughs in Bay of Bengal. When there are a lot of low pressure troughs in Bay of Bengal, most of them get pushed into the Indian landmass, mainland India, and they pull the monsoon winds towards themselves, causing rainfall in the plains region, northern plains. Okay, so low pressure troughs and westerlies. Westerlies which blow over the northern plains during winter season are still continuing. Now, if westerlies are strong over the northern plains during the summer season as well, that is not good for the monsoons. The westerlies should shift upwards beyond Himalayas. Okay, during winters they come down towards northern plains, but during summer season they move northwards above Himalayan region. Now this has not happened. So this is basically not allowing northern plains to pull monsoon towards itself. Understand the point? So we'll talk about these 5 factors in detail in geography lectures, but right now just remember them. So there are 5 factors responsible for monsoon. El Nino, La Nina. So El Nino, low rainfall. Downward Madden-Julian oscillation, low rainfall. Weak Somalian jet stream, low rainfall. Less low pressure troughs in Bay of Bengal, low rainfall. And westerlies still continuing over the northern plains, low rainfall. Here, remember these 5 facts. Now, here is the regional map. Like Vidarbha region has received 62% less rainfall, East and Northeast India 44% less, Deccan Plateau 19% less, and Goa belt, Konkan belt 81% less. Okay, so this is the standard deviation from the normal. And well, the impact of that. This table is given in your notes. Do take a look at this. But we'll talk about the impact of this. If monsoon season is bad this year, what impact will it have on Indian society, on India's economy? So socio-economic. So let's talk about the impact. A prolonged severe June monsoon deficit triggers a cascade of vulnerabilities across intersecting sectors of the economy. Number one, well, there will be agrarian shock, farm distress, which would lead to drop in food supply because the yields are going to drop. Drop in food supply, demand for food is high, supply falls. This would lead to food inflation. This is bad. Then, well, there are many hydropower projects which depend on monsoon rainfall for these reservoirs to get filled up and generate hydropower. Now, if rainfall would be scanty, then what would happen? These hydro reservoirs would get depleted. And if they are in a depleted state, their capacity to generate or their potential to generate hydropower also dwindles down, diminishes. So this would reduce the capacity of hydroelectric power plants to produce hydropower. Already it is very difficult to satisfy the demand of all people as far as electricity is concerned, especially when the summers are really hot. The peak demand for electricity has increased. We need all the electricity that we can produce. If hydropower plants are going to produce less electricity, that is really a worrying sign for India. Okay, and then because farmers are not getting rainfall, they would have to depend on groundwater irrigation. That would lead to groundwater extraction, and these groundwater aquifers are already in their depleted state. This would lead to water shortage in future. So these are the 3 bad impacts or bad consequences of poor monsoon season. Now, what is the way forward for us? How can we prepare for this? Okay, so this is the way forward. transitioning to micro-targeted agri-forecasting, agricultural forecasting, weather forecasting, micro, village-wise. Okay. Then expanding smart seed and crop subsidies, increase crop subsidies for farmers, increase the availability of smart seeds. Now, what are smart seeds? Seeds that are already attuned to low rainfall, low chemical fertilizers. Okay. They are already drought resistant. Make them more available. And well, decoupling the power grid via solarization. Okay, already farmers are dependent on electricity for pumps, water pumps to extract groundwater. Well, encourage farmers to use solar pumps, so their dependency on electricity would be less. So we'll save a lot of power in this area. Okay, PM Kusum is one such scheme. Remember the name of the scheme: distributing solar powered water pumps to farmers. If farmers are going to use these solar pumps, they would use less of electricity. We'll save a lot of electricity, and that would be beneficial because electricity is in short supply these days. Demand has risen. Supply is still more or less constant. Clear? So that would be all as far as this topic is concerned. Now let's quickly shift our focus to next news item, and that is surging thermal cooling demand. Well, the summers were really hot this season, okay? Coupled with a lot of heat wave incidents. Now, because of that, well, there has been record demand for air conditioners. There has been record demand for electricity to power these air conditioners. Also, now a significant chunk of our population resides in urban areas. And urban areas suffer from this phenomena called urban heat island effect, okay, which makes urban areas hotter than surrounding villages, right? So there has been record demand for cooling solutions. Now, cooling solutions, the only cooling solution that is available to us is, well, air conditioners, right? Now, there has been very high demand for air conditioners. There has been very high demand for power for air conditioners, okay? Now, the problem is that India has made certain environmental commitments. Now, if India is going to support this rising demand for air conditioners, those environmental commitments would suffer, right? So what is this paradox and what can be the way forward? How can we solve this problem of cooling in urban areas as well as the surrounding villages? How can we provide cooling solutions which are not dependent on air conditioners, ACs? Let's talk about this, okay? So surging thermal cooling demand. So extreme day and night heat waves coupled with an alarming humidity surge pushed India's energy infrastructure to its limit. As per Central Electricity Authority data, it shows that the peak electricity demand has increased by 10% as compared to last year. So we have broken all records. The primary driver behind this structural electricity surge is the exponential demand for thermal cooling services, air conditioners, refrigerations, and cooling systems. Clear? So these are the primary drivers. Already a lot of India is, well, except North India, well, monsoon has reached many parts of the country, which increases humidity also in these areas. Now, humidity plus heat is a really challenging thing, okay? Dry heat is all right. You can still cool yourself by sweating. But when it's humidity, your sweat also doesn't allow your body to cool, okay? Because there is high humidity. So heat plus humidity really makes air conditioners essential. We all know about this, right? Now, the thing is that much of this electricity demand is coming from, well, power, air conditioners, refrigerators. The problem is that these refrigerators or air conditioners have hydrofluorocarbon gases which get emitted when they are powered, okay, or there is some leak. Basically, the compressor of these air conditioners have hydrofluorocarbons. Now, we already have a protocol called Montreal Protocol, okay, and Montreal Protocol was about phasing out chlorofluorocarbons, hydrofluorocarbons. Then there was an amendment made to Montreal Protocol called the Kigali Agreement. The Kigali Agreement said that we need to quickly phase out hydrofluorocarbons because hydrofluorocarbons are, well, an important greenhouse gas, okay, which is increasing global warming. So the problem over here is that air conditioners use hydrofluorocarbons. And India has made a commitment in Kigali that we are going to phase out hydrofluorocarbons. Now, India Either India can follow Kigali and tell all its people don't use ACs. Is that possible? Because you can't ask people not to use ACs because already they are suffering from heat wave like conditions. So India is stuck in this problem. Okay, now what is the solution? Let's talk about this. Okay. Now, scientific drivers. What are the reasons behind this demand for ACs? Wet bulb temperature. Now, you should know what this thing is called, wet bulb temperature. Wet bulb temperature is the temperature along with high humidity. Okay. So, temperature plus humidity is wet bulb temperature. It is generally said that if the wet bulb temperature is 35 degrees Celsius, which means that the temperature is 35 degrees Celsius along with high humidity, it is kind of impossible for humans to cool their bodies. And it is really fatal also. Why? Because 35 degrees Celsius is a hot temperature. With humidity, humans sweat. Generally, we sweat so as to cool our body, lower our body temperature. Because when that sweat evaporates, our body cools down. But if there is high humidity, that sweat doesn't get evaporated. And that is the reason our body, can't cool down. So this is what wet bulb temperature is. The threshold is 35 degrees Celsius. It cannot be more than that. Now, because wet bulb temperatures have reached 35 degrees Celsius in many parts of the country, there is requirement for ACs. Okay. Then the problem is, because there is high humidity, water vapor in the atmosphere also acts like a greenhouse gas and it traps the heat. So during the day, the earth gets hot, the buildings get hot. During night time, these hot buildings emit heat, they lose heat. Okay. Now, if there is high water vapor in the atmosphere, that heat gets trapped within the atmosphere. And the temperatures, the nighttime temperatures are also still very high. Generally, nights are supposed to be cooler so that people can cool off. But now even nights are hot because of high humidity. So there is demand for ACs. You understand this point, right? Now, what is the issue with power grid? Electricity. This is another problem that India is facing. The sudden widespread use of space cooling appliances has exposed structural imbalances within India's power generation mix. Now, what is this problem? This problem is known as the duck curve effect. Okay. Well, if we are using more electricity and that electricity is coming from solar, there is no need to worry because solar energy doesn't emit greenhouse gases. But if that electricity is coming from thermal power plants, which are powered by burning coal, then it's a problem because that emits greenhouse gases. The thing is that during the day, solar power can take care of your electricity needs. But during night time, the sun is not shining out in the sky. So you can't produce solar energy. And if there is still very high demand of ACs during night time, which it actually is, then the responsibility is on the shoulders of thermal power plants, which emits a lot of greenhouse gases. Okay. Now, there can be a solution to this problem. You still can use solar electricity for nighttime, but that solution is batteries. So, produce surplus solar energy during the day, store it in batteries, and use these batteries to power your appliances during nighttime. But India does not have a good battery infrastructure also, battery energy storage system. So, we have to be dependent on coal, which again is a problem. India's commitments under Paris Agreement, they get challenged. Okay. Now, yes, let's talk about Kigali. So under Kigali, India has made a commitment to phase out hydrofluorocarbons from refrigeration and ACs. Okay, these are those commitments. This is the timeline for India's commitment. By 2047, we will have no hydrofluorocarbons. And we will use alternatives to hydrofluorocarbons in the compressors of ACs. Okay, that's not important. What is important is that, what to do now? Okay, there is high demand for ACs. How to reduce this demand for ACs and side by side help people cool themselves. So we need to look for alternative cooling solutions, especially in urban areas without ACs. So what are these alternative cooling solutions? Take a look at this graphic. Okay, now one technology solution is use this HC290 propane in your ACs instead of HFCs. Because if you use this HC290 propane, your Kigali commitments would get fulfilled and people would cool themselves. But this is not a long-term solution. Okay, the long-term solution is Well, paint buildings. The rooftops of the buildings should be painted with high albedo, cool roofs, so that much of the sun rays get reflected and the buildings are cool. Or look for these cooling solutions, district cooling systems. Well, the entire district is, these are pipes, okay, as you can see, and these pipes are pumping highly cold water, chilled water. This water is chilled in this station. So this is a centralized cooling system for the entire city. This can be used. And yes, well, existing ACs which have HFCs, well, the existing ACs which are not serviced timely, well, HFCs are leaked from these ACs. Okay, there are leakages. So we need skilled professionals, skilled technicians to capture this leak and repair it. India is short of these skilled professionals as well. So we need to train these skilled professionals. So this is the strategy, the India Cooling Solution, India Cooling Action Plan, ICAP. India has basically talked about this strategy, and the government has announced that it is going to implement this strategy. Make sense? Okay. Now let's shift our focus to third news item, and that is ground level ozone concentrations. Now look, as far as air pollution is concerned, well, India is not performing that well. Okay, we all know about it. But most of the times when it comes to air pollution, we focus mainly on winter air pollution, especially around the Delhi NCR region or the northern plains. But the summers also produces its own kinds of air pollutants, okay, which really harm your health, which really harm agriculture also. So we need to focus on summer air pollution as well. Generally, most of our air action plans focus on winter air pollution when there is this issue of stubble burning and all that. We ignore summer air pollution, and that is a mistake. Now, the biggest air pollutant during the summer months in northern India, well, that is ozone, ground level ozone, okay, which is also known as tropospheric ozone. Now, ozone is really beneficial for us provided it is in the upper layers of the atmosphere, the stratosphere. Stratospheric ozone is very good because it blocks the harmful UV rays from coming to Earth. But ozone in the lower layers of atmosphere where we can inhale it, that is really bad, and that is on the rise. Okay, so let's talk about this. Okay, so yeah, ground level ozone concentrations. So while public attention and policy frameworks like Graded Response Action Plan historically treat air pollution as cold, stagnant winter emergency, especially with respect to particulate matter 2.5, a series of landmark nationwide studies published in June 2026 has exposed a hidden summer crisis, and that is ground level or tropospheric. This is the lowest layer of atmosphere, troposphere. Tropospheric ozone. Now, the thing is that ozone doesn't get emitted from any source. Tropospheric ozone is basically categorized as a secondary pollutant. Now, what is a secondary pollutant? You need to be familiar with this term. Primary air pollutants are those pollutants which are released into the atmosphere from some source, maybe the exhaust fumes of cars, maybe industrial emissions, or XYZ. Okay, those are primary pollutants. Secondary pollutants are those which get created due to some chemical reaction between primary air pollutants. Okay, it is not emitted directly by anything. It gets created. Okay. Now, how is ozone created in the lower layers of the atmosphere? This is the chemical reaction. Okay, look, a very significant primary air pollutant is nitrous oxides. Nitrous oxide, nitrogen dioxide, the NOx. Okay. Now, another primary pollutant is volatile organic compounds. Okay. When nitrogen oxides react with volatile organic compounds, this reaction happens only in the presence of high heat and UV sunlight. When there is ample heat and UV sunlight, which is during the summer months, nitrogen oxides and volatile organic compounds, they react to produce ozone. And that is how ozone is created in the lower atmosphere. Now, let me tell this to you. Let me break this down also. This is again important. Okay. You all know how ozone is created. The thing is that ozone is created near those industrial areas which emit a lot of nitrous oxides, okay, or where there is vehicular traffic. But the thing is that when ozone gets created and there is enough nitrous oxide that is also created from industrial emissions, it creates nitrogen dioxide and oxygen. Now, the thing is, and this is really serious, focus on this, areas which continuously pollute the environment by emitting nitrous oxide, they are saved from ozone. Why? Because, well, ozone reacts with nitrous oxide, but the nearby surrounding residential areas or villages, well, ozone spreads out to those areas and those areas lack nitrous oxide. So ozone stays there, and this ozone is harmful. So the factories and vehicles that are creating ozone, those areas are not suffering from ozone because they continuously emit nitrous oxide. So ozone gets converted back to oxygen. But the surrounding areas, they suffer from ozone pollution. You understand this point, right? Now, regional hotspots, well, it says that most Indian cities produce ozone beyond World Health Organization safety guidelines. Indo-Gangetic plains are the hotspot, and this time around, even Leh Ladakh regions are suffering from ozone, tropospheric ozone. So this has been revealed in the latest study. Now, what is the impact of ozone? Well, this is the health impact of ozone. It causes heart disease, respiratory diseases, okay? But it also destroys agriculture, because ozone is a phytotoxic gas. What happens is that plants inhale ozone, and this ozone, well, then destroys the cell membrane and all the important tissues of plants. So it's harmful for agriculture as well. So food security is vulnerable because of this. Human health is vulnerable because of this. Now, what is the way forward? Well, we don't just need winter action plans. We need year-round dedicated action plans. We need early warning systems, okay? So that, well, and micro-level early warning systems so that administrators can take action based on these warnings. Make sense? That's about it. Now let's quickly shift our focus to last news item, and that is smart seed coating technology. Now, what is this smart seed coating technology? Well, seeds are coated with some material. That material makes them, well, water resistant, or not water resistant, drought resistant. So they require less water to grow. They don't even require fertilizers because the nutrients, nitrogen, phosphorus, potassium, NPK, are coated on that seed. So you coat the seed in such a way that it doesn't require that much fertilizers, it doesn't require that much insecticides, pesticides, and even water. Don't you think these seeds would reduce the input cost of farmers? Plus, these seeds would be less dependent on monsoons also. And it has been shown that these seeds have a higher yield also. Right? Now, this coating has been recently discovered in India. And now most of the seeds would be coated with this coating, and now India's agriculture would improve. So what is this coating? Which research institution developed this? What are the benefits? Let's talk about the entire gamut of things. Let's begin. So smart seed coating technology. So as part of India's multi-pronged strategy to build climate resilient agriculture, Indian Council of Agricultural Research's Indian Institute of Oilseed Research, Hyderabad, announced the successful validation and patenting of its breakthrough smart seed coating technology. Now, through this smart seed coating technology, well, it would give a boost to sustainable farming, resource use efficiency because less water, less fertilizers would be required, reducing production risks because now it won't be dependent on monsoon or that much dependent on monsoon. Okay, and because you will be using less insecticides, fertilizers, so that is, well, sustainable farming, because overuse of fertilizers harms your soil. That won't be required anymore. Now, what is the process of this coating? Okay, so step 1 is, well, primer layer. Raw seeds are initially treated with specialized eco-friendly biopolymer adhesive, something that sticks. So a biopolymer adhesive is there, you coat it with that. Okay, it's a sticky layer. Then on this sticky layer, you add biological inputs. Okay, you add rhizobacterium, which fixes nitrogen. These are helpful bacteria for the crops. Then nutritional coating, like nitrogen, phosphorus, potassium, boron, and other micronutrients that plants require. And then crop protection agents. Some fungicides, some insecticides are added, which is third layer of coating. These coats are put on this biopolymer primer. And then, well, because there is this biopolymer bubble that is created around these seeds, well, all these nutrients, they very slowly come out of the seeds and get absorbed in the nearby soil, helping the plant to grow. So this is what the coating does, and these are the 3 steps. Clear? Now, well, there were some trials on groundnut, okay, and it has shown some promising results. Okay, so groundnut seeds were coated, and in Kharif season it improved its yield. In Rabi season it improved its yield. So it was, I mean, the agricultural input cost came down by 17%, and overall it performed well in maize, chickpea, cotton, mustard also. So these were the results of the test of this coating. Now, why is this a game changer? Because it is tailored for rain-fed agricultural vulnerabilities. Farmers that use monsoon rainfall, they don't have irrigation facilities, they completely rely on monsoon rainfall. Farmers that perform rain-fed agriculture, well, they are vulnerable to, well, anomalies in the monsoon. Not anymore with these seeds. Then, complete environmental safety, because there are no microplastics in these coatings. Okay, and radical improvement in resource use efficiency. Obviously, less fertilizers would be used, less pesticides would be used. It will be a win-win situation. Less pesticides would be used, less water would be used. Sustainable agriculture. Clear? Make sense? And that would be all. With that, we conclude today's session. So thank you so much for watching, everyone. And I'm sure it has added value to your preparation. I'm sure about it. Now, just, well, don't forget to perform these 2 steps, okay? If you want to add more value, just remember these 2 things. Number 1, be consistent and regular with this lecture series. Make this lecture series a part of your daily routine. And number 2, revise this lecture from the notes provided by us. Do not forget to do that. All right. On that note, I shall take your leave with the promise of seeing you again with another set of news items. Thank you, everyone.